All right, welcome back. So in this video, we're going to be going through 3 examples on how to solve quadratic equations by a process we call completing the square. This is the second video on how to solve quadratic equations by completing the square. I'm going to try and link the first video to this video in case you didn't see the introductory video on completing the square. I'm going to try. It's going to be the first time I do it, so we'll see how it goes. If it doesn't link up, sorry, you just got to go and find the first one. So a main reason why we use completing the square is because we have quadratic equations that aren't factorable. So it's not easy for us to solve. So we have this process completing the square that makes it a little bit easier to work with any quadratic equation that isn't factorable when we need to solve it. So just want to go through again the core concept of completing the square. So we always want a binomial on one side that includes our quadratic term as well as our linear term, right? So our x squared and our bx. What we're going to be doing is we're going to take half of b, which is the coefficient of x, and we're going to square that, and then we're going to add it to that binomial. If we have an equation where it turns out to be x squared plus bx, let's say, is equal to c, what we're going to find is that we're going to rewrite it when we add half of b squared we're going to add that. Oh, I'm running out of room. We're going to add it to both sides because we need equality, right? What we do to one side of the equation, we need to do to the other side of the equation. And then we're going to factor this trinomial and simplify the opposite side. So this turns out to be a perfect square trinomial, which results in x plus half of b squared. And then is going to be equal to the c plus half of b squared value, whatever that is. And then we solve from there, right? So let's go through 3 examples on how to do this process. It says solve the equation by completing the square and leave it as a radical. Personally, I love to leave it as radicals because radicals are exact values. Decimals sometimes are approximations or they are rounded, so it's not the exact value. And radicals to me are the way to leave it. Your teacher might ask differently, but for our purposes, we're going to leave it as a radical. So notice we have x squared minus 2x is equal to 3. We want that a value to be 1, and we have that done as 1. We also have a binomial with our quadratic and our linear term on one side and our constant on the other. So this is the perfect setup. So what we're going to have to do is take half of our b value. Our b value is negative 2. So we're going to, remember, it's b over 2. That translates into negative 2 over 2, which is negative 1. We're going to take that and we're going to square it. So we get positive 1. We're going to add 1 to both sides. Get x squared minus 2x plus 1 is now equal to 3 plus 1. So we can simplify the left-hand side. This turns into a perfect square trinomial where we can simplify as x now plus half of the b value. Well, half of the b value is negative 1. So we're going to have x minus 1 squared is now equal to whatever 3 plus 1 is, which we know is 4. These are some easy numbers for us, which are nice. In order to get that x minus 1 all by itself, we have to take the inverse of squaring, which is taking the square root of both sides, so it cancels out with the square root operation, or the square ring operation, I should say. So we get x minus 1 is equal to now plus or minus the square root of 4. We can simplify the square root of 4 to be 2. We now want to get that x all by itself, so we have to add 1 to both sides. I'm going to scroll. So now we get that x is equal to 1 plus or minus 2. We can simplify this down. So we get x is equal to 1 plus 2, which is 3. and x is equal to 1 minus 2, which is negative 1. All right, sweet. Cool beans. Here we go. Cool. Let's solve this equation by completing the square. And again, we're going to leave it as a radical if we get one. So we have m squared plus 12m is equal to negative 8. I notice I already have a binomial on the left-hand side with my quadratic and my linear term, and my constant is over on the right-hand side. This is perfect. So now we're going to take half of b. Again, our b is 12. Oh, and we're going to take half of b now because we see the quadratic coefficient of a is 1. So this is the perfect setup for us. So remember, it's b over 2 translates into 12 over 2, which is 6. We're now going to take 6 and we're going to square that, and we get 36. So now we're going to add 36 to both sides of the equation. So we get m squared plus 12m plus 36 is equal to negative 8 plus 36. So now we can simplify the left-hand side. Again, it's a perfect square trinomial. It's going to go into x now plus half of b. And half of b, again, is 6. So it's going to be x plus 6 squared is equal to negative 8 plus 36, which is 28. We now need to simplify because we want to get that x plus 6 all by itself. So we take the square root of both sides. We get x plus 6 is equal now to plus or minus the square root of 28. We can simplify the square root of 28. Let's do that over on the right-hand side over here. So we have the square root of 28 breaks down to square root 4 times the square root of 7. We know this to be 2. So we get 2 root 7. So I'm just going to rewrite that. We get x plus 6 is equal to now plus or minus 2 root 7. And now we want to solve for x. We want to subtract 6 on both sides. I like to have this term in the front. That way it's easier for us to read. So we have x is equal to negative 6 plus or minus 2 root 7. And for all intents and purposes right now, that's perfectly fine. Sweet, nice job. All right, cool. One more. You got this. So now we have a little bit more complicated of a quadratic. We have 3g squared minus 24g plus 27 is equal to 0. We need a binomial of our quadratic and linear term on one side, and they're currently on the left-hand side, so we need to move this 27 over. We have to subtract 27 on both sides. So we get 3g squared minus 24g is now equal to negative 27. We need that a value to be 1, so I have to divide everything by the coefficient of our quadratic, which is 3. So boop, bye-bye. So now we get g squared minus 8g is equal to negative 9. And now we can complete the square. So we have g squared minus 8g is equal to negative 9. We need to take half of that b value. Our b value again is negative 8. So it's b over 2. This translates into negative 8 over 2, which is negative 4. We're going to take negative 4, the whole value squared, and give us 16. So we're going to have to add 16 to both sides. So we get, nope, that's not the color. Thank you. There we go. We get g squared minus 8g plus 16 is equal to negative 9 plus 16. Let me scroll. Boop. So now we can simplify the left-hand side. It's a perfect trinomial. It's going to be g plus half of b. Well, half of b was negative 4, so it's going to be g minus 4 is equal now to negative 9 plus 6, which is 7. Sorry, squared. So now we need to cancel out the square ring by taking the square root of both sides. We get g minus 4 is equal now to plus or minus the square root of 7. We can't simplify the square root of 7. So now we want to get that g all by itself. We're going to add 4 to both sides. When we do that, we get g is equal to 4 plus or minus the square root of 7. Sweet. And that's how we complete the square. Great job, folks. If you have any questions, please reach out. Stay safe. Miss you. Have a good one.